So we're going to start with one more example of a monad, and it's a monad that is built with a small library that provides a way of building parsers using do notation. So the library, which we're going to show how to build shortly, introduces a new type, an abstract type called a parser for an A. So it's abstract in the sense that you don't get to see what's inside this type, how this type is built. And that's nothing new. We don't get to see inside the type IO or gen. We don't know how they're represented internally. We just know we have a type and we have a bunch of functions and do notation for combining them and building them. So the same goes for this parser type. We're going to see that we can build parsers from other parsers, and we have certain basic simple parsers that we can start with. Now, in order to run a parser, we're going to have a function for that. So, and the function contains something that you'll recognize as what we were calling a parser last time, a function from strings to maybe a thing and a string. So we have a function that allows us to run a parser. So its first argument is a parser, this abstract thing. And if you give it a first argument, then you get a function which turns strings into maybe a thing and a string. So this runs the parser on a string to maybe get a thing and a string. So let's see this thing in action by using an example. So the example that we're going to use to begin with is a little data type for phone numbers. So I'm imagining a world in which there are two ways of writing down phone numbers. One is with the international notation, and the other is with just a local number, or a national number if you like. So in this example, I've introduced a data type to represent the two possible ways of representing a number. This one I'm going to call a global number, and a global number has two parts. It has the international country code, which I'm representing by an int. That'll be the 46 in this example, and then the rest of the number. That's this part of the number, and that'll be the global constructor. That constructs a global phone number. And the other possibility is you have a local phone number, which is just an int. And here's how I might display something of this type to get back something that looks like this. So if it's a global number, I'll put a plus character on the front, and I'll show the number, the country code, show a space character, and then show the rest. And if it's a local number, I just show the number. Actually, probably local numbers begin with a 0, so I might want to put a 0 on the front of that. Maybe I'll do that as well. Okay, so let's switch to the library. So here's the type that I just introduced, and you see I actually did modify that and put a 0 on the front. And what I'm doing is importing a library that contains the parse function, the type of parser, and a bunch of basic building blocks for parser instructions. So you view these now as instructions for parsing a value of type A. So I'm going to build a parser which takes the representations of phone numbers and turns them into values in this data type. So that's the example I'm going to use. Let me just compile this to make sure everything is in order. And I can then show you with these examples here, we could show the number work, and that prints out in a rather boring way, and the home number is a little bit more interesting. So what we're going to do is we're going to build a parser, something which will convert strings like this into values in the data structure like this. So going from strings to values in the data type. We're going to do it in a number of steps. So in each step, we're going to introduce some library functions, some functions from the parser library. So let's start with a country code. I'm going to introduce a couple of things here. Parser for characters, a specific character, and parser for a digit. So when we want to parse a country code, that's this bit here, we want to parse a plus symbol, we want to parse a specific character, and then we want to parse exactly 2 digits. And from those things, we're going to construct a number. In this case, it would be the number 46. So remember now that parsers are instructions. So that means we can build instructions using do notation. So what does a country code do? It's going to first parse a character plus. So there's a parser that will help us do that. It's called char, with a small c. And the type of char from the parsing library, if you tell it what character you're looking for, it builds you a parser for that character. For example, char of the plus character will be a parser that only parses the plus character. So let's run that parser. To run that parser, we use the parse function, and we need some string to try and parse. If we start with the plus character, for example, plus 4, 6, then we succeed. What do we mean when we say succeed? It means we get the thing we were looking for and the rest of the string. If, on the other hand, we give it something which doesn't start with a plus character, this char plus parser will fail. It will give us nothing. So when we give nothing, that's what we say, what we mean when we say it fails. So this is a parser that produces the plus character, and this one, when we parse 46, it fails. Okay. So the do notation here is used as follows. What we're going to do is parse the character plus. We're not going to do anything with it because we're not really interested in it. We're just going to make sure it's there. If we succeed, then the next thing we do is to parse a digit. And there's a parser for that called digit. So if we parse a digit, it will get the first digit. If we parse something which doesn't start with, we try and parse something which doesn't start with a digit, then we get nothing. For example, if it starts with a letter instead of a digit, we don't get anything. So we're going to parse a digit, but we want to know what this digit is. So we're going to use the do notation in the same style. Let D be the name of the digit. Well, let's call it D1. It's the first digit. If that succeeds, then we're going to do the same thing again. D2 is another digit. We're going to get 2 digits. And then what are we going to do? Well, then the parser is going to return the value that it wants to build. It's going to return, and it's going to take these 2 digits, D1 and D2, might be digits 1, 2, and turn them into an int. So how do we turn something, a string of digits, into an int? Well, actually, we can use the function read for that. It's a standard function, but we need to, read has to, of course, know what we're trying to get. We're trying to get an int here. In this example, it will know what it's trying to get. So we can read something, and this is a built-in function which takes anything readable and turns it into an int. It's a sort of parser, but you have to remember we can only apply this when it works, because if we apply it to something that's not what we're looking for, we actually get an error. So we can read here the list D1, D2, the 2 digits as a string. So now we can parse the country code from, let's parse the string we get from show we can parse the country code from some string, and it will, in this case, give us the plus, the 46, the part of the number that we're trying to build. Okay, so that's a parser for country code. We've introduced 3 things actually: the library functions char, which parses a specific character; the digit parser, which parses a digit, any digit, as long as it is a digit; and the way that we use do notation with the parsers, which is to parse a thing, and if you fail, then the whole thing fails, but if you succeed, you carry on to the next step. We're parsing with digit parser. If we succeed, we'll call the resulting digit that we get D1, and we'll go to the next step, and so on. And when we're done, the final result that we return is the value of the return function, and that means in this case, it's this part. And when we want to run a parser, well, then we have to use the parse function to do that. If we apply that to work, for example, that doesn't have a country code on the front, and so we get nothing. The parsing fails. Okay, let's have a look at some more functions. How do we parse not just 2 digits, but a whole natural number, a non-negative number? Well, the way that we can do that is we can use another function, library function, called one or more. And one or more takes a parser for a thing and turns it into a parser for a whole list of things. So that's going to be very useful. So to parse a natural number, I'm going to do the following. I'm going to parse 1 or more digits. So if I'm going to parse a number, I have to have at least 1 digit. So it's 1 or more digits. I've got to spell that right. And let's give that a name. Let's call that DS, the digits. And now we're going to convert those digits into an int. And we can do that using the read function. So we're going to return read of DS. So there's our parser for a natural number. So we can parse using the nat parser. Let me reload that file. I can't remember if I did that. Reload that. Let's parse using the nat parser, the string 1, 2, 3 plus 4, 5, 6. What would you expect to get there? you get the number 123 and the rest of the string. And of course, if we start trying to parse something which doesn't start with a natural number for whatever reason, it might be because there's junk, or it might be because it isn't a natural number, or it might be because the string is empty, there is nothing there at all. In all of those cases, we get nothing. In other words, we fail. The parsing fails. Okay, so now we're at the stage where we can define a parser for our phone number. We don't need that, but what we're going to do is introduce one final library function, which is written as an operator, 3 pluses. So the type of +++ is, it's a way of combining 2 parsers into one. So I have a parser for an A, I have another parser for an A, and this is going to build me a new parser for an A. And so what it's going to do is, the way this operator works, is that it's going to try to parse using this parser, and if it succeeds, that's the result. But if it fails, then it will move on and parse with this parser. So it's first parse with this guy, then parse with this guy if this one fails. And whatever result you get from this one, if you use it, that's the final result. Okay? So try to parse one thing. If you fail, try to parse the other. And that's particularly useful here because when we want to parse a phone number, there are 2 possible representations. So we're going to write 2 parsers, one for a local number and the other one for a global number. So we're going to first try to parse it as a local number. If we fail, then we'll parse it as a global number. And it doesn't actually matter in this case which order we write them in, because local numbers and global numbers look completely different. This one always has a plus on the front. This one will never have a plus on the front. Okay, so let's define those things as make them local definitions. So local P, that's the easier case. A local number is just a nat. So what we're going to do is the following. We're going to parse a natural number and call that n. And then with that natural number, we're simply going to build a value in the phone number data type using the constructor local. And that's the value we're going to return. So we're going to return the local. So we're going to run this parser. If it succeeds, we get an n and then return something in the right data type, a phone number. And if, of course, we fail to find a number, this whole thing will fail. Okay. And the global, the other guy, we're also going to use a do notation, and this one's a little bit more involved because this one involves several steps. So the first thing we do with a global one is to parse a country code. The country code is what we get from the function that we defined earlier, the country code. So we parse a country code, that will give us a number, I'm calling it CC. And if we found a country code, then we're going to expect to find a space. Now you could make the space optional here. I'll leave that as an exercise. So I'm going to parse a space. I'm going to parse the character, the space character. I'm not going to do anything with it, just going to make sure it's there. After I parse the space character, then I'm going to parse a number. That'll be the rest of the code. And once I've done that, I've got all the pieces I need to build my result. Don't need to look at any more of the input. I can return the global number applied to the country code and the rest of the number. So now we should be able to parse a phone number, so we can run the parser, a phone number on, what was the example we had? It was show number home. The home number was a global guy, and the other one was a work number, which was a local number. Okay, let's look at one more example. So the example is parsing a whole list of phone numbers where the elements in the list are separated by commas or semicolons. Okay, let's have a go at this. So we assume we have a list of phone numbers, perhaps something like, let's build a list. If we were to show the home number and join that together with, let's say, a semicolon and a work number, that would be one example. So that is one number, semicolon, then another number. And we're going to assume that we have one or more of these things separated by the semicolon. So a phone list, we're going to build a parser for a whole phone list, parser for a list of things, and we're going to use a chain function. So the chain function is a bit like the one we defined ourselves for parsing expressions. It's a little bit simpler. The type is a little bit simpler. So it parses a list of A's which are separated by B's. So in our example, what we're interested in, a list of phone numbers separated by semicolons. So it takes as two arguments, the things we're looking for and a parser for the things that separate them, and builds a parser for a list of things. So it gives you parses a whole list of them. So the B's here, you see that they're not present in the result. They're the kind of bits in between that we need to know that are there. We need to know that there are semicolons between every phone number, but we don't need to actually, they're not part of the result. The result will be a list of the things. So that's the chain parser. What are we going to build then? Well, actually a phone list we don't need to do. We can do it all with chain, I believe. We should be able to do a chain of phone numbers. So we use our phone parser that we just defined. Separated by, well, here's a start. We could just separate it by the character semicolon. So that's a parser, which will parse a semicolon. So this will parse a chain of things, chain of phone numbers separated by things which are parsable by that parser. So if we try that out, can't remember what we're looking at. We're looking at that example that we defined earlier. Where was it? That one there. So the example was that thing, and if we use the phone list parser on that example, oops, I must remember to parse. Then we see we build the list of phone numbers by repeatedly parsing a phone number and parsing the semicolon. But what I said was that it could be semicolon or comma. So if we want to allow a semicolon or comma, well, one way to do that would be just say, well, either the character semicolon or the character comma. That would be one way of doing it. There is another way we might see later, which is to use a function called sat, which takes a predicate. So we want to parse anything which satisfies the separator. Maybe I can give an example of that. Let's just comment that out. So sat takes a predicate from characters to bool. If it's a certain kind of character, then you can parse it. So for example, sat is digit is the parser for digits. In fact, that's how digit is defined. Digit is defined to be, it is the isDigit. So isDigit is just one of the functions from data.char, which I think I've imported here. We'll soon find out. So if we satisfy the function, the property isDigit, then we can parse a digit from a string. And if it's not a digit, then it fails. So that's actually the definition of the digit parser. It's just sat isDigit. So here what we could do is we could sat, let's call it sep, a function sep, where a sep of some character C is the test that C is an element of the list of separator characters, which we're going to write as either a semicolon or a comma. We could add other things as well if we wanted to.